Today we are going to talk about rational functions. So the main objective of this classes today is to graph the rational function. So follow the 9-step strategy to sketch the graph of a rational function. That's the main objective of this topic. Use the 9-step strategy to graph the rational function. So the given rational function is f of x equals 4x plus 20 divided by x square minus 3x minus 10. So the very first step is to find the domain. So generally speaking, the domain is the set of all x values for which the function is defined. So in the case of rational function, we know that the denominator of this function should not be equal to 0, because if the denominator is 0, that makes the function undefined. So we need to exclude from the domain of this function all x values that makes this denominator 0. So in order to find that, we need to factor the denominator. So x square minus 3x minus 10, the factors are x minus 5, x plus 2. And we know that the domain doesn't include x equals 5 or x equals negative 2. So we need to exclude those points from the domain of this function. If you consider a number line, if you plot the points like negative 2 and 5, so we need to exclude these points. So using the interval notation, we can write the domain of this function as negative infinity to negative 2. Negative 2 is not included, so that's why we use the parenthesis union. Then negative 2 to 5, both parentheses for negative 2 and 5, because those points are not included, union 5 to infinity, 5 is also not included. So the domain of this function is negative infinity to negative 2, union negative 2 to 5, union 5 to infinity. And the second step is to identify any removable discontinuity. So for that, we already factored the denominator, and we can also factorize the numerator. 4 is a common factor, so factor out 4 times x plus 5. And we can see that there are no common factors in the numerator and the denominator. So we can conclude that there is no removable discontinuity. Then the next step is to find the symmetry. So let's check for the symmetry. So to find the symmetry, we have to find f of negative x. So that means we have to replace every x in the function by negative x. And when you replace x by negative x, if you get the same function, then you can say that it is an even function. It is symmetric about the y-axis. But if you get the opposite of the given function, then you can say that it is an odd function. And then it is symmetric about the origin. So in this case, replace x by negative x. So 4 times negative x plus 20 divided by negative x, the whole quantity squared, minus 3 times negative x minus 10. And this is negative 4x plus 20. And negative x, the whole quantity square, is positive x square. And these two negative signs makes this term positive, so plus 3x minus 10. So you can see that this is not same as the original function. And also it is not same as the opposite of the original function. So this is the original function. It is not the opposite of the original function. So we can conclude that no origin or no y-axis symmetry. So the next step is to find the y-intercept. So our given function is 4x plus 20 over x square minus 3x minus 10. So to find the y-intercept, set x equals 0 in the given function. So when you look at the y-intercept, so when you set 0 for the given function, all these quantities become 0. So we have 20 divided by negative 10, so negative 2. So again, this is our original function. To find the x-intercept, that is the fifth step. So set the function, set the rational function equals 0. So when you set a rational function equals 0, that means the numerator is 0. So 4x plus 20 equals 0. So solve for x equals negative 20. So x equals negative 5. So that is the x-intercepts. And to find the vertical asymptotes, the rule is that we need to factor the numerator and the denominator of the function. So we got that. If you have any common factors, then cancel that. Then set the denominator to 0. In this case, there are no common factors in the numerator and denominator. So we need to set the denominator, that is x minus 5 equals 0 and x plus 2 equal to 0. So you can see that when you set x minus 5 equals 0, so you will get x equals 5. When you set x plus 2 equal to 0, you will get x equals negative 2. So the vertical asymptotes are x equals negative 2 and x equals 5. And remember, always need to write the vertical asymptotes in terms of an equation because it is a line. So if you write negative 2 or 5, then you will not get any points. So it should be a line. So x equals negative 2 and x equals 5. Okay, this is very important. Then along with the vertical asymptotes, we need to check the behavior of the graph of the function on each side of the vertical asymptotes. So we know that the vertical asymptotes are negative 2 and 5. So this will help you to graph the function easily. So using test values, we can determine the behavior of the graph near the vertical asymptotes. So we have to take some points on each side of the vertical asymptotes. So as x approaches negative 2 from the left, you can consider a point like negative 3. You can and substitute in the function value. You can see that the function is approaching to, or you will get a positive value. That means the function is approaching to infinity. And also when you consider a value on the right side of this x, so you can see that, for example, if you consider negative 1, and if you substitute that value in the given function, you will get a negative value for the function. So we can say that the function is approaching to negative infinity. And regarding 5, if you consider a value to the left of 5, for example, it is like if you substitute 4, and you can see that as x approaches 5 from the left, you can see that the function is approaching to negative infinity. In other words, if you substitute a value of x as like 4, that is a value to the left of 5, you will get the function value as negative. So you can conclude that as x approaches 5 from the left, f of x is approaching to negative infinity. Similarly, consider a value to the right of 5 and substitute in the function, you will get a positive value. So you can conclude that as x approaches 5 from the right, the function is approaching to infinity. So this will help you to graph the rational function. Then the seventh step is to find the horizontal asymptote and our original functions. So we can find the horizontal asymptotes by looking at the degree of the numerator and the denominator. So our function is, you can see that our function is f of x equals 4x plus 20 divided by x squared minus 3x minus 10. So the degree of the numerator is less than the degree of the denominator. So as we have studied earlier, the horizontal asymptote in this case is always y equals 0. And then the next step, that's the 8th step, is to plot points, choosing values of x between each x-intercepts and values of x on each side of, on either side of all vertical asymptotes. So we know that the x-intercepts are -2 and 5, and also the the x-intercept is -5, and the vertical asymptotes are -2 and 5. So we need to take some values between and beyond these x-intercept and also the vertical asymptotes. Okay, so let's take a value like -6 on to the left of -5. So you will get a value like -0.09. And if you choose a value in between -5 and -2, you can choose any value. So for convenience, I chose -4. So f of -4, substitute this value in the function. You will get 0.222. So 2 is repeating. And choose another value between -2 and 5. Let's say -1. So when you substitute -1 in the function, you will get -2.67. It's approximately -2.67. And I chose another value in between -2 and 5, 4. I chose the value 4. So f of 4, that is -6. And one more value that is to the right of 5. So that is 6. So f of 6 is 5.5. Now, using all this information, we need to sketch the graph. So to sketch the graph, first we need to graph the vertical asymptotes. So x equals -2 and x equals 5. And also we need to plot the x-intercept, that is -5. And the y-intercept is 0, -2. And we know that the graph touches the x-intercept and the y-intercept. And to get the graph over here, we know that as x approaches -2 from the left, the graph is approaching to infinity. So here the graph is going upward. And also we have given some points. So we took some points, like for example, corresponding to -4, you can see that we got the value 0.22. So it's somewhere between 0 and 1, close to this part. So, and also you know that the graph, this is the x-intercept, so it passes through this point. And remember, the graph never intersect a vertical asymptote, but it may intersect the horizontal asymptote. So one part of the graph looks like this. And we know that there is no symmetry for, there is no y-axis or origin symmetry, and the graph passes through the y-intercept. And also you can see that when you study the behavior of the graph near the vertical asymptotes, we took a point to the right of -2. So as x approaches -2 from the right, you can see that f of x is approaching to -infinity. So this side is going down. And when you consider this vertical asymptote, and we have already seen that as x approaches 5 from the left, the graph is again approaching to -infinity. So it is going down. So that is another part of the graph. Okay. Then when you look at this part of the graph, and you can see that as x approaches 5 from the right, the graph is going up, or f of x is approaching to infinity. And we have taken some points like corresponding to x equals 6, we got 5.5. So that is a point over there. So we can complete the graph, the last part of the graph by graphing this curve. So this is the graph of our rational function f of x equals 4x plus 20 divided by x squared minus 3x minus 10. So hope you got an idea about how to graph the rational function using the 9-step strategy. So we graph the rational function using the 9-step strategy. Thank you.